So, hello, how are you doing? Everything fine? So, let's get rid of things. So, welcome to Spring Security. Who uses Spring Security? Who loves Spring Security? Who hates it? I will talk about the security filter chain a bit later, so that's my most annoying thing all the time. So I propose maybe some things to help you out to trace down what maybe could be the cause why it is failing. So yeah, we will have a deep dive over the latest Spring Security releases starting from 6.3. So about me, it's just a short introduction about myself. So I'm coming from Novatech, so this will be my last talk for that company. So we have been merged recently with a much bigger company called CGI. So we become from 300 employees to 90,000 employees now once in a time. So very surprising to me, but yeah, last talk for me. So if you want to connect with me, you can connect via LinkedIn. You can also ask questions after the talk as well. So what we are talking about, so we start with 6.3. 6.3 introduced some new things like compromised password checking, the OAuth token exchange. Unfortunately, I cannot show that demo as I wanted because it just broke down this morning. the demo gods are not with me, so it worked yesterday evening. I tested, and this morning I have no clue why it does not work. But I will just show how it really works behind the scenes, and then we also skip that one. But I have many other demos to show, so that's not not bad. So we will also talk about the security filter chain. There's also a new feature inside Spring now to have some error detection if you do wrong ordering of your security filter chains. Then I will show the one-time token login and also the passkeys. That will be an interesting one. I hope that works. So I also tested that. So we will start with compromised password checking and the OAuth token exchange. So who knows the have I been pawned password API? So yeah, that's a great thing. You should go to that and type in your password. So in that case, it's quite safe because it's not transmitted as a password as it is. It's always hashed before, and it's just comparing hashes if that is a password that is known to be broken. So if that password is known to be broken, please don't use that password anymore. So typical passwords like 1, 2, 3, 4, 5, 6 for sure are broken for sure. So don't use that one. And in Spring now you can also implement password policies, including a check of compromised passwords. So that also checks against the API of Troy Hunt's have I been pawned REST API, and then you get back if that is a compromised password. So I have also a GitHub repository with all the demos on it. If you want to try it out later, you can also just get the link to that. I will show it again at the end of the talk. So let's see if that works. So is that big enough? So what you have to do to use the compromised password checking, you just have to register a new bean, as usual in Spring. And that's basically all. So that bean can then be used at different locations. Like, what do I have? I have a password policy implemented myself here, so quite easy. So a password should have a minimum length of 12. It could have a maximum length of 100. So one advice, don't restrict your users for having too few characters on the password. So it's a bad idea to restrict passwords having just a maximum length of 20. You can do it up to 100, 120. And also don't restrict passwords too much with you have to choose 2 uppercase characters, you have to choose these symbols and only these symbols, and this gets really complicated. So just make it big and permit every character, even emojis, strange characters, to be typed in as a password. And the last thing what I'm doing here now is if it's a compromised password. So that's the checker. It has a simple check method. And then you can check decision is compromised. If it's compromised, then this is a bad thing. So I've used that in different places. I have a register request where I can register new users. Let's try that out a bit. So I've started it already, I think. So I use pretty much the HTTP client of IntelliJ, so that's quite easy. So I also implemented a check password thing here. So this password is compromised. Don't use password. You can also include that in a register endpoint. So if I try to register that one, so that also won't work. Maybe we can try it out with some longer password, if that will work. So yeah, so that seems not be a compromised password, so that worked successfully. Quite easy to implement, so extend your password policies with compromised password checking. So, and even better, get rid of passwords completely. So that's the best one you can do. So we want to get rid of passwords at all. So passwords are really root cause of all security problems nowadays. And we have two possibilities. I will show quickly the OAuth token exchange next. So that's one way to get rid of passwords in your own applications as well. So you get the passwords only in the identity provider, and you are free of any passwords. You only have to deal with tokens. And even more advanced are the Passkeys way of using security. Then you don't need any password anymore. So the OAuth token exchange, who knows the OAuth token exchange? So the OAuth token exchange is also a great thing to deal with the different tokens that you have in your applications. So usually it's quite easy to have a client. You have one microservice on the back end, then the client gets a token, sends it to that one microservice. But it becomes interesting if you have more than one microservice, then this other microservice may be some other domain, and it would be a bad idea to authenticate with the same JSON Web Token to each and every microservice in your company. Imagine you have an Amazon recommendation system that is not really risky. Then you can use a JSON Web Token here. Then you have another backend that does all the payment stuff that is much more risky, and it's a bad idea to use the same JSON Web Token for these two services. And token exchange is a good thing to get rid of that security surface. So you get a JSON Web Token from the client to the first resource server. This is also a short-lived JSON Web Token. Then you can exchange that token with the authorization server. You just send the token to the authorization server and get back a fresh JSON Web Token. And the authorization server then can have policies to decide, can this token have a longer expiration time? What audience can the token have? For which microservice is that token intended to be used? So if you then change the token, it's not possible anymore, for example, with that JSON Web Token from the client to access resource server B, because this is restricted for a specific audience that you only get from the token exchange. So if one has stolen that short-lived token, then is not able to directly access the resource server B because that is restricted for some other JSON Web Token. Some other problem that you often have is some using of a business process management engine, for example. Here you have the problem that here you might need really long-lived tokens because you have long processes going on and you don't want to get a new token each and every time in your long process. So you can also have some long-lived token that is exchanged in a special way for that business process management engine. So these are the real-world problems that you usually have when you are dealing with lots of microservices and all that JSON Web Token stuff. So the normal thing that I see in 75% of the project is that the project just use the JSON Web Token and do a token relay to each and every microservice. But this is a bad practice, and you should not do that. You can also implement two ways for the OAuth token exchange. We have the impersonation feature, where you act as a user that gets some more privileges as part of the token, like a new audience, for example, new roles that can come from the token exchange. And you have a delegation pattern where you then act as a different user. You get then a subject token and a new actor token, and the actor token is really the actor who does the thing. But still there is a subject token, so the original user is also kept here, so that's the delegation pattern. So you can do both patterns with token exchange. So I've set up a demo session. As told, the demo does not work at the moment. So in my demo session, if you are part of the workshop later, then it might work. So I try to repair it until that time. So I have here a client, a token exchange resource server that does the token exchange, and I have a target resource server that only works with that restricted audience. So that's the demo here. I quickly just show how it is basically set up. What you really need at first is a authorization server. So I use the Spring authorization server. Who uses Spring authorization server? So it's a great thing. So it gets new features all the time. So we have also a slide a bit later on that. So it's quite easy to use the resource server, the Spring authorization server. So if you want to register, for example, a new client, the OAuth client, that's quite easy. You just register a client here with some client ID, client secret, your authentication methods, your authorization grant type. This is for the client now, the registration, and I have a special one as well for the token exchange. For the token exchange, you just also implement some client registration, but here you use the authorization grant type token exchange. You don't need a redirect URI or something like that because it does not interact with a client. So it's only working on the server side. You can also then write different scopes here. What I also have done, let me just check. I've also put a new audience here as part of the exchange token. So I check if the token exchange client is here working. And if this is the token exchange client, I just put a specific audience in the token that restricts it from being used only to that target microservice. And on the target microservice, let me check that. So where do we have token exchange? So this is the target resource server. Also just a standard resource server like it used to be. So you always have to put the issuer URI so it can validate the JSON Web Tokens against the authorization server, and I also restricted the audience to that specific audience, and so you can only use JSON Web Tokens that have been exchanged before. And the exchange of these tokens is in the token exchange server. Let's look also inside here. So the interesting part is here. So you build an OAuth authorized client manager because it has to know so what kind of authorization grant to use for get a new token in that case. And then you can configure a token exchange OAuth authorized client provider that you then just add as a provider to that OAuth authorized client provider. And this typically is the thing that you return. And with that, you can then just use that in your API, for example, if you get a token in. So that's basically the access token that comes in when you access the resource server. You can get the token, get the subject, the audience. But what you then basically do with that token is you use that OAuth authorize request with the client registration. This is the client registration I've shown before for the token exchange at the authorization server. Then you give it the principal, so that's the original access token. And the real exchange happens here. So if you call authorize client manager authorize with authorize request, then behind the scenes it does the token exchange and then can use that fresh access token, so not the original one, but the exchange one. As we are not seeing the real demo, so I have just prepared some small demo that you can see how the token exchange really looks like. Let's start a resource server and the token exchange. Where do we have the resource server? So here we are. So also interesting for the IntelliJ HTTP client. So who uses the IntelliJ HTTP client? So the good thing is you can use the whole OAuth flows with the IntelliJ HTTP client. So that makes it also a good replacement, for example, for Postman, which got quite commercial in latest time. So we are also looking for replacements everywhere for Postman at the moment. And the HTTP client of IntelliJ is a great thing because it can automatically grab tokens from the authorization server. Like here, this is the authorization server, I can just log in. And then I should get back some user info information. So that's the answer of the authorization server from the user info endpoint. So that's quite easy. You only have to declare some environment file for your authorization server, and then it grabs directly the tokens from that configuration. So now I have requested a token, and I can reuse that token now for the OAuth token exchange. So I just use that same token here. What you then have to specify the token endpoint of the authorization server and a special grant type for the token exchange. You also have then specify the subject token, what token type you transmit to the server, and what token type you want to request from the server. And you can also specify new scopes for that exchange token. So let's look into that one. So we should have got a token. So that's the new access token, the exchange one. So that's basically how OAuth 2 token exchange works behind the scenes. And Spring Security usually does it for you, unless the demo would work. So let's move on to the next one. So that was the OAuth token exchange. So Spring Security 6.3 has much more to offer as new additions. So if you watched Daniel's talk yesterday, which was great, so he talked pretty much of all these authorization stuff, so I skipped that for today. I like pretty much the annotation parameters and also that you can now authorize domain objects. Like checking if one user can see the account number or the account amount and stuff like that, and other user cannot see that. And also have that authorization denied handler implementation, so to mask out fields basically, so in that case. So that's a great thing that you can do starting with 6.3. So 6.4 added some more things like the security filter chain, configuration error detection, the one-time token login, and the Passkey authentication. So three big, at least two bigger additions. Let's check the error detection. So that's That's a picture from the documentation of Spring Security. You all know the different supply filter chains. You have ordering, so you have multiple ones. And sometimes you go into trouble and you ask yourself, which one is the current one that is used at the moment? And sometimes the ordering is wrong, so then the more generic one is the first one, and it grabs all the requests, and you're wondering why it does not end up with my specific one. And good news is that you can have this checked now with Spring Security. Let me also show that one. Let me just stop the authorization server first. So in that case, I have a security filter chain defined, one correct one and one invalid one. Let's check the two versions here. So that would be the correct one. So you have here, in that case, order number 1. So that should be the first one to be accessed with a security matcher only for the actuator request. In that case, I use a different kind of authorization for that one, like the health endpoint should be accessible to all people. And I have a second one, the generic one, that is then for my APIs. And if you're doing it wrong, then you just switch cases. So you use that one first with the generic one, and the specific one comes later. And that's a typical error that can happen from time to time. And if I now just start the invalid one, we will directly see what will happen. So we already got an error here. You have to jump to the last error here. So it basically tells it at the end. In Spring, all the time you have to go to the end of the stack trace to find the root cause. It also tells you, so yeah, that any request filter should be published last. So that's the thing that gets, so that filter will never get invoked. It tells me, so if you get such an error message, then please recheck the ordering of your filter chains. So there are more debugging features that you can use. I think most of you already know the, do we have it here? So know that you can switch on the trace level for the logging. So then you see all the details, which filter chain was matched, which one was not matched. Did it find a match to my pattern and stuff like that? You can also define a debug flag on the enable web security annotation, where then it also puts some debug mode on, where you can also check if the correct filters are in my chain. So it puts out all the filters of the chain, and you can also recheck if one filter is missing, like for example the CSRF filter, or there's some wrong login filter, so I missed the OAuth filter that I wanted to have. So these are all the possibilities to nail down some errors here. So that was the filter chain. Next is the one-time token login. Let's check the time. We have lots of time. The one-time token login is also from Spring 6.4. So that one-time token login is really usable for easy logins for some application that the user doesn't really want to register for, which is really a one-time usage for some application. Just give some email address to the application. I just want maybe get some download from some company, and I don't want to register with all my details. So just send the email, and then it sends you back a unique link. With that unique link, then you can directly log in and get this information that you only want once. Don't implement that as a regular login feature in your usual normal enterprise applications. You will annoy people if they always have to check their email account for each and every login. So that's not a good usability. So let's check how that works. So first, that stopped already, so yeah, that's good. So let's start a one-time token login. So let's check. So I always have to look up how it works, otherwise I forget. So this is what it looks like if you have configured the one-time token login. I showed later, a bit later, how it is configured really. So then you type in some username, like for example, a test username. I hope that is also up. So no email. So I also just started up some simple email server that I then get the link sent to, hopefully. So just some email address. Now it's sent. So I received a one-time token from Spring Security. Then I was lazy and did not put out a HTML format for my email account. Then you just paste that in, and then you can directly log in into your application. So ready, you are logged in, and then you can just grab the information that you wanted to have. So a quite easy one to implement. And it's also quite easy to implement. Let me just check the one-time token demo to the configuration. So you just need one line here, one-time token login, as usual with defaults, is sufficient. The second one that you have to implement is a magic link one-time token handler that then tells Spring Security what to do, where to send the one-time link, and here you're free to do whatever you want. I just grab the token value here, and then I just create a simple mail message in that case and send it to my email server. And that's basically all you have to do for the one-time token login, so also a quite easy one. So let's stop that again. So that was the demo for the one-time token login. As mentioned, please only use that for really easy login, for simple login features, not for your regular applications. So next up now are Passkeys. Who knows Passkeys already? Who uses Passkeys regularly already? So rarely used. So all the important services now offer Passkeys, like GitHub. If you go to GitHub and stuff like Google, etc., they all use Passkeys at the moment already. So Passkeys are really a big advantage. So you get much faster possibilities to log in into websites, because last year I was also on an identity conference, and there was really a great sentence. So what the user cares about is not the authentication. What the user cares about is what comes after the authentication. So we should make it really easy for the user to actually log in, and Passkeys could be a way to do that. So it works also across users' devices. I will show that also with my iPhone, if that works out, to log in cross-device, it's phishing-resistant, strong cryptographic, so it works with public-private keys. So these are basically the passkeys. It is a great replacement for passwords. So lots of services now use it as a second factor, but you even can get rid of passwords completely and just use passkeys. So this is how it works in the real world. So it's supported on all important operating system with one acceptance. So Linux is still a bit annoying here. So if you're using Linux, you have to configure it maybe with YubiKeys. There is a possibility to have a support for that on Linux as well. But they don't have a cross-device support yet. Also, Windows is working on that. So I use Apple today because that is a really nice working workflow to show. You can use it with the iOS together. You can also use Android with the Google Password Manager. So it's supported by the new password application of Apple with the Windows Hello. You can also use third-party apps like 1Password or the Bitwarden as two examples of the external passwords. I'm often asked, so how these different terms relate. So you hear about WebAuthn, you hear about Passkeys, you hear about FIDO2. So that's why I've written, so WebAuthn is really the engine behind all that stuff. So it has the basic specifications, the basic implementations of all. So Passkeys is more like a marketing word. So it's more the user-friendly car built around the motor engine. And Passkeys are really the FIDO2 sign-in credentials. So FIDO2 really defines how the credentials should look like. How do Passkeys work? You have two flows to follow. You have to first register yourself a passkey. So this creates a key pair on a safe place. You have to have a hardware device thing, like on your iPhone, you have some hardware part inside that stores safely the private key. So it creates a private key and sends the public key to the server. You want to register the passkey, and if you later authenticate to that same server, it has already the public key, and you then sign some challenge with your private key that gets sent to the server, and with the public key, the server can validate if that is really a signed request from you with your user identities. And that's basically all. If you want to have the full picture, I will also share the slides later on, then you can also look into, for example, the WebAuthn 4J framework, which is beneath the surface in Spring Security as well, which does the hard work behind the scenes with the whole protocol stuff here. So we see an authenticator and client and server, so these are the participants of the passkey flow. So the authenticator is a safe place that creates the private public keys, stores the private key and stuff like that. The client is the binding thing here, and on the server has to then also validate if that signing is correct and with the public key. So that's basically what is happening here. So, before going on, I just want to show the Passkeys demo. So let's check if we have, I've stopped that already. So for the Passkeys, I have to switch to my other thing. So it's running. So if you want to configure passkeys, that's also quite easy. So just 4 lines of configuration. So you just type in WebAuthn, then you have to specify some relaying party name to remember. The really interesting thing is the relaying party ID and the allowed origin. So you have to specify really the domain where your request is coming from. So to identify then when using the passkeys, the user has some chance to identify, is this the correct domain I want to have here? And the allowed origins should also exactly match to that domain that you give up there. So basically it runs on localhost. If you're doing it on production, for sure, you should have a real domain name and also HTTPS as a protocol. So that's also a strict requirement here. So that's basically all you have to configure here. And let's see if it works. So I have to switch on my phone again to make it work. Do I have Bluetooth on? No. So let's see if that works. So So with the passkeys, you recognize you get also a new login feature automatically that is displayed. At first, you have to register for a passkey. So that's the first step. So at first, you have to log in with your user credentials as before, because it has to verify that you are really the user. Then I provided some simple application here. It only has some registration for passkeys. Then you can call the API as a test that it really works with the passkey, and you can also log out again. So if you want to register that, then you can just type in some remembering name as a label. And now comes the interesting part. Now you have different possibilities. So I have one password installed, for example. I don't use that at the moment, so maybe I'll try it later if we have time. But you can also then click on here and check that I want to use Apple in that case, directly on my device with the password application that goes into the keychain on Apple. So just get my thumb here, and my passkey is registered. Then I have to log out again so I can check that passkey. And now I can try out if I can log in, not with my one password. Now I can also log in with that one, but the more interesting part, hopefully that works, will be that I'm now registered that on my keychain, so it should also be available on my iPhone as well. So because that's cross-device. So what I get here, I can now select, if I want to do different things, I want to select my phone here. So let me check if that works. So it takes some time. So now I have to select the correct one. So, logged in. So I just had to type in that in my smartphone, and I'm logged in here. And I also call my API hello user in that case. So a really good usability. Just use your Face ID on the iPhone, and you basically can log in a really short time with your passkey without typing any password anymore. So really quick thing here. So I can also show how it looks like doing it with one password as another one. So you can also register multiple passkeys here. So in that case, then I want to use my one password. I can save it here with localhost. Log out again. No. Type it correctly. Then I can just sign in with my one password, and that also works. So you can also register multiple passkeys at your service. So that also works out quite well. So that was the passkey thing. So as you have seen, really easy to use, really easy to implement. You still can also reconfigure all behind the scenes, but it's quite easy to get it running, basically. So if you want to change your designs and stuff like that, then you have more work to do as well, but it basically works out of the box with only really small configuration. Just try it out on your devices. It should work with Windows as well. So I'm looking forward to a workshop. So what devices people bring to the workshop. So that will be interesting if it works. So further improvements of Spring Security 6.4. So we have also OAuth 2 support for the new REST client. So you can use the new REST client with the OAuth 2, so it also gets automatic then a Bureau token included, and you can call other services with the REST client. There's OpenSAML 5 support now for the authorization. There's also even more extension to annotation templates so that you can also use that for authentication principles and the current security context, and also some improved Kotlin support for the pre-post filter stuff. Yeah. So with 6.5, there was not really big new things. The biggest thing is that the support for the demonstrating proof of possession. A really long sentence. Who knows that specification? So who uses single-page applications? Who wants to get rid of token stealing in the single-page application? So that is one good thing to get rid of that. So it basically binds token now. I have a separate slide just in a moment. You can also have now persistence for the web authentication thing, so you can also basically store not only in memory your passkeys, what I've done here, you can basically also store that in some database now. And you also can customize the one-time token request that I've shown to your needs in more. Then you also have the possibility to now also use the new JWT profile for OAuth2, where you can also specify different types of the tokens. So there's a possibility to indicate this is really an access token. So the 80 plus JWT is a sign that this is intended to be used as an access token, because JWT tokens can be used for different things, like for some attestations, some logout scenarios. So, and you never know if this is really a JSON web token that is intended to present it as an access token for my microservice. And if that type is then given, then you are sure this is really an access token. And there's support now also in Spring Security for handling these kind of types now. So for that depop thing, this is a token binding, which also with cryptographic things like public-private key cryptographic can bind a token even to a single-page application now. So you have to use the newest Spring Security 6.5 and also the newest authorization server 1.5. These both provide support for that new specification. And you have to also use some compatible client framework that also supports your Angular application, for example, for doing that depop thing. And with that implemented, it's really difficult for an attacker to really steal tokens from your client. So because only that valid client has the proof of private public key infrastructure to send the cryptographically signed token to the server, and the server then can really check if that is cryptographically correct and is only coming from that valid client. So no attacker can access anymore your servers with that. So what's coming with the next one, with the next Spring Security version? So that's the final part now, so as we are also running out of time. So 7.0, so it's not quite clear on the horizon, so it's also a bit far away, so what features might sneak in as well. So you have one breaking change, so you will have a mandatory usage of the Lambda DSL. So who knows who uses the new DSL already? So I don't use the old one anymore. So I was always annoying to put an end in between it, and then I have to figure out where should I use an end, where don't need an end in between, and that was quite annoying. So it's much easier with that new DSL, and the old one will go away. So be prepared that you cannot use that old one anymore in the next major version. So also lots of deprecated code will be removed from that version. And also the proof key for code exchange that you now is recommended for using of single page application is becoming the default for all applications, not only for public clients, but also for server-side web frameworks like Spring Timeleaf and stuff like that. So that's recommended for all kind of web clients now. Yeah, there's also a lot of going on in the Spring authorization server, so that's my bonus slide here. So with 1.3, we got the mutual TLS, client certificate bound access token, which is usable for server-side web frameworks that can have a mutual TLS binding mechanism. So that's the counterpart of that DPOP thing I showed previously. For single-page applications, you can only use the DPOP thing because they cannot use that mutual TLS infrastructure as they are not a server-side framework. The OAuth token exchange we have seen. Then there's also a multi-tenancy feature, so you can have multiple issuers now in your authorization server. So not only one endpoint, so with one issuer, with a single issuer, but you can have issuer 1, issuer 2, with all that authorization flows that implements then maybe for different domains in your company. 1.4. This is a great thing I can recommend. If you're not using token binding, then at least use the backend for frontend pattern for your single-page application. That also frees the token from the browser side. You have some API gateway in between that also handles the whole token flow for you and also stores the token on the server side. And there's a great example now also in the Spring Authorization repository that you can use as a starting point that provides a simple single-page application, all the applications involved with a gateway authorization server to really implement such backend for front-end applications. There's also the prompt none support now in Spring Authorization Server that you basically use used as a trick for your single-page application nowadays, so to not have to log in all the time. So you just send your request all the time with a prompt equals none, and then the authorization server, if there is still a session going on, doesn't ask for a new login form, and you're logged in again. So that frees also the single-page application from using refresh tokens, which are also a bit risky on single-page applications. And then the newest one is now the support for the DPOP thing. And you have also a new one, the pushed authorization requests. So as you have seen in OAuth 2, that the original authorization request is also put out as a GET request. So it puts lots of request parameters in a URL, which you usually shouldn't do in that case. And because it also has client ID and some maybe sensitive data inside. And with that pushed authorization, you can basically first do a post request with all the parameters, and you get back a unique link from the authorization server that you then try for the second request that then pushes really the authorization request, but that it doesn't include any sensitive parameter anymore. So also frees from security prone things here. So if you're joining my workshop, then you will also have the possibility to try it out yourself. And with that, that was all what I was to have to show.